A lot of this will overlap with what I talked about the other day, so it's stuff you've already done and reviewed. So we'll go fairly quickly through this. Stop me if you have any questions here. Reference angle is the positive acute angle from the terminal side to the x-axis. So that's what we're using to associate pi over 6, pi over 4, pi over 3 with the special right triangles, is that reference angle. For example, I might have an angle all the way over here. I would call theta the reference angle here. And that reference angle in this case, I tried to draw it so it looks like it's corresponding to a 30-degree angle. So in this case, the reference angle is maybe 30 degrees here. And that would correspond to a 210 degrees, or in radians, that would be 7 pi over 6. So when I'm asking what is cosine or sine of 7 pi over 6, you are using a reference angle of 30 degrees when you're thinking about the triangle. All right, and then we talked briefly about this. Start in quadrant 1 and go counterclockwise. We have the acronym All Students Take Calculus, which we all, of course, are planning to do that. That helps us to remember the signs of the 3 trig functions, sine, tangent, and cosine. See them underlined here. In the first quadrant, all of them are positive, sine, cosine, and tangent. In the second quadrant, only sine is positive. Tangent and cosine are each negative there. In the third quadrant, only tangent is positive. And then in the fourth quadrant, only cosine is positive. And so all students take calculus as you go around counterclockwise from the first quadrant to the fourth. Will help you to remember the sign. I personally don't use that acronym to remember the signs. I just picture the unit circle and where I am in terms of the left or right of the y-axis. So I'm just thinking in terms of coordinates. So that circle I gave you yesterday that you filled in, that's what I'm picturing in my mind. I'll even draw pictures. I mentioned that yesterday. Draw pictures of what the coterminal angle, where it lands, in terms of what quadrant it's in. And then I use reference angles and the quadrant I'm in to figure out the sign. But all students take calculus. One thing we have to do, one thing I have to do, is as I'm evaluating the special angles, like pi over 6, pi over 4, pi over 3, or 4 pi over 3, or 5 pi over 3, I have to think about where it's located, what quadrant it's in, and pay attention to the signs. That's a big part of this. So it says, consider a point P in the coordinate plane. You can find the trig functions of the angle formed through P by using the coordinates of P. So in other words, if I drop a perpendicular to the positive x-axis, make that a right angle, this is x, this is y, and this is r. And so by definition, sine of theta, which is equal to, oh, there's theta right there, which is equal to the opposite over the hypotenuse, would be equal to, in this case, y over r. So y is representing my opposite side from the angle theta, and r is my radius. Cosine of theta, which is equal to adjacent over hypotenuse, is equal to x over r. And tangent of theta, which is equal to opposite over adjacent, gives me y over x. So those are the 3 trig ratios that we primarily work with. There are 3 others. I'll reintroduce you to those a little bit later in the notes. But Those are the 3 primary ones. And my statement was that if you can learn cosine and sine of theta at the special angles in the first quadrant from there, then you can calculate any of the others. So we'll practice that some more today after this. Now, what we're focusing on is when r is 1, we're on the unit circle. That's what this is down here. R is not always 1. I mean, that's what we were doing yesterday. So if R is not 1, like in the case of this coordinate, 5, 12, let's go ahead and draw that. Then we have to find R using the Pythagorean theorem. So 5, 12 would be over 5 and up 12, so maybe farther up. That would be the point 5, 12. If I draw a reference triangle, drop a perpendicular here, this is theta. This is 5, and this is 12. So there's my picture. And what I need to do is find the missing hypotenuse here before I can evaluate it. So my goal is to find cosine of theta, sine of theta, and tangent of theta, and simplify it if necessary. But let's see here. Can we find the radius? We have a right triangle. We're given 2 legs. Pythagoras will help us with that. We have, call this r. R squared equals 5 squared plus 12 squared. Some of you may already know that this is a Pythagorean triple. Maybe you recognize it. It is. It's 5, 12, 13. So it's really helpful if you know your triples. But 5, 12, 13 will show up quite a bit. So r equals 13 here. And now I have all 3 pieces of the triangle. I can go ahead and, using the definitions, find the sine, cosine, and tangent of the angle. So cosine of theta is equal to the adjacent, which is 5, over the hypotenuse 13. Sine of theta is the opposite, 12, over the hypotenuse 13. And then tangent of theta is opposite, 12, over adjacent, 5. So that's an example of given a coordinate, finding the, creating a right triangle, finding the cosine, sine, and tangent ratios. And that one, that particular coordinate, r is not equal to 1. Now for a given angle, like if I had a 30-degree or a 60-degree angle, 90-degree angle, it doesn't matter what size the radius is because those circles are similar to each other, so we're going to get the same ratio as we do with our unit circle. Not sure what this angle is. These aren't ratios we recognize. You would recognize the ratios here if it were one of the specialized angles. We'll talk about how to find that angle later. Like everything we do in mathematics, we reverse the process. So I'm giving you the angle measurement, you're going to give me the ratio, and eventually I'll give you the ratio and you'll give me the angle. I think you probably did that last year too. Did you do inverse trig functions last year? Where he said sine of theta equals 1/2, find theta and everything. Remember? Okay, we'll do that this year. Actually, this semester. So -3, -2 would be 3 to the left and 2 down. If I draw my reference triangle, looks like this. This is theta right here for my reference angle. So I've gone 3 left and 2 down, and I need to find r. So this one is not a Pythagorean triple. I have r squared equals 2 squared plus 3 squared. So that tells me r is equal to the square root of 13. So now I have all 3 pieces. So now that I have all 3 pieces, I can, using the definition, label cosine of theta. So remember, theta's right here. There's theta right there. So the adjacent side would be what? 3. If theta's right here, the adjacent side would be 3. So theta, what's that? For theta is going to be coming out from the origin. It's going to be between that ray that comes out from the origin and the x-axis. Okay, so there's theta. So cosine of theta will be adjacent 3 over hypotenuse, which is root 13. Now sine is going to be, I'm going to take a step back, think about sine. I'm over to the left of the y-axis, so it'll be negative. And the other thing we need to do here is simplify the radical. Okay. This is correct. It's in exact form. As you move on into higher levels of calculus, you might even leave it like this, but for our purposes, we're going to go ahead and simplify it. Do you remember how to simplify this? Yeah. That. So I get negative 3 root 13 over 13. So that's cosine of theta. Sine of theta is equal to opposite 2 over hypotenuse root 13. It is also negative, and I'm going to simplify it in the same way. So we get negative 2 root 13 over 13. Somewhere on here we find some space for tangent. I think we can do tangent right here. Tangent theta is going to equal the opposite, which is 2, over the adjacent 3. Unfortunately, I don't have to simplify that one. So there they are, the 3 trig ratios, cosine, sine, and tangent. That's just given some coordinate on the coordinate plane. We're going to be doing quite a bit more with this next semester. Probably, if you're in physics, you've probably done a little bit, some trig maybe with coordinates in the plane. Yeah, relates to vectors. All right, so now consider, and we already considered this. We've already done this before. Consider the point P to be on the unit circle with the radius equal to 1. Well, that's convenient because when the radius is equal to 1, then cosine of theta is exactly equal to x, and sine of theta is exactly equal to y when the radius is 1. Right?
Yeah. For the last one, for tan, why is it 2 negative?
It should be negative. Good catch. It should be negative. Well, actually, it shouldn't. You know why?
Oh.
Sorry, I missed. It is positive because it's negative and a negative. So that goes back to my all students take calculus here. So all students take tangent is also positive here. Good question. So my coordinate here can be thought of as cosine of theta, comma sine of theta. And so that's what allows us, it's the thumbs up, we have the thumbs up for that. When we created that unit circle the other day and labeled those coordinates all the way around corresponding to our special right triangles, we had a listing all the way around, one circuit around the unit circle of our cosine and sine ratios for the special right triangles. So the radius is 1, makes it kind of nice. The x-coordinate is cosine theta, the y-coordinate is sine theta. So when it says find the 3 trig functions if the terminal side is passing through the point on the unit circle. I highlighted unit circle because that means now we can apply this idea. In other words, cosine theta is equal to whatever the x-coordinate is. So here's my unit circle. If I am right here at 1, 0 on my unit circle, then that tells me, let's do sine theta first. I'll show you why. That tells me sine of theta is going to be 0. Cosine theta is equal to 1. And then tangent theta, this is kind of like our table we had constructed with the special right triangles. Tangent theta is sine theta over cosine theta, or 0 over 1, which is 0. Right. And then B, if I have a coordinate at negative 1/2, comma, root 3 over 2. So a little bit to the left, and then up high here. So maybe you can picture which radian measure that goes with. I don't know if you can picture it or not, if you're there yet. But if I draw in my little right triangle here, there's my right triangle, there's theta, my reference angle theta. I'm 1/2 to the left, and root 3 over 2 up. And all I'm doing is just labeling the positive lengths of those legs. But this coordinate right here tells me what cosine and sine of theta are. So sine of theta is the y-coordinate, which is root 3 over 2. And cosine of theta is the x-coordinate, negative 1/2. And then tangent theta is the ratio of those two, root 3 over 2 over negative 1/2. It's nice when the 2's are both on the bottom. You could flip and multiply, or just notice, hey, if the 2's both on the bottom, they're going to cancel here. This is going to equal negative root 3. Might have to picture flipping the bottom and then canceling. But if you have 2's on the bottoms of both those fractions, they cancel out. It leaves you with negative root 3. Check my signs. I think my signs are good here. Positive. Sine is positive over here. Cosine is negative. There's tangent. All right. So you did some of this for homework last night. The importance of finding a coterminal angle that is between 0 and 2 pi is that then it corresponds to one of those coordinates on the unit circle. And once it corresponds to one of those coordinates on the unit circle, then we can find the sine and cosine ratios, and then from those, any of the other 4 trigonometric ratios. So 17 pi over 3, it's helpful, I think, to just think of it as a mixed number. 3 goes in 5 times with 2 left over, so 5 and 2/3 pi. So what's happening here is I go around 2 pi and then 4 pi, and then I have 1 and 2/3 pi left over, which 1 and 2/3 pi is the same as 5 pi over 3. So really, the coterminal angle between 0 and 2 pi here would be 5 pi over 3. So I go around twice, and then I'm going to go, okay, 5 pi over 3 is all the way back over to here. And so what you see in blue there, that's my degree measure, or angle measure, I should say. It's not degree, it's angle measure in radians that is between 0 and 2 pi. So if you needed to reference your unit circle, you could. You have your unit circle, you look at it, and so cosine and sine are going to be the x and y coordinates that you have down there. So if you have your unit circle that we constructed yesterday, you can look at it. But cosine theta is equal to, I'm not as far out here, so which value is that going to be? Not as far out, so we have 2 values, root 3 over 2 and 1/2. Root 3 over 2 is bigger than 1/2, so if I'm not as far out, it's 1/2. And then farther down, the root 3 over 2, and then I got to check my sign. It's got to be negative because sine is corresponding to the y coordinates. So that's sine and cosine. So the angle that's coterminal with 17 pi over 3 is what I've circled, 5 pi over 3. And I really probably should say, okay, 5 pi over 3 is what I'm plugging in here. Sorry about that. I don't need to call it theta. Let's call it 5 pi over 3. You could put those in for theta. We'll do that in the next one. So 9 pi over 2. I think this showed up on your sheet the other day. 9 pi over 2 is equal to 4.5 pi. So in terms of a coterminal angle between 0 and 2 pi, what's it going to be? Not 3 pi over 2. We're going to go around once, and then twice, and then I have pi over 2. Just pi over 2 is all it's left over. So I'm going to be right up here. There's my angle. It's a 90-degree angle, or pi over 2. And so the angle that's coterminal is pi over 2. And so I'm asking for cosine of pi over 2 and sine of pi over 2. This coordinate up here is 0, 1. And so cosine of pi over 2 is going to be 0, and sine of pi over 2 is 1. That's it. Right, this one, 11 pi over 4, is the same as 2 and 3/4. 2 goes in twice with 3 left over. 2 and 3/4 pi. So I go around once. That's the 2 pi. So my coterminal angle around once, and then I go around 3/4 of a pi, so that's going to be right here. It's 1/4 pi, 2 pi over 4, and then 3 pi over 4. So right here is my angle. So 3/4 pi is my coterminal angle between 0 and 2 pi. And so I'm going to calculate cosine of that, cosine of 3 pi over 4, and sine of 3 pi over 4. And cosine of 3, the pi over 4, multiples of pi over 4 are easy. Those are the ones that are root 2 over 2. You just got to know what the sign is, and that's what the picture helps me to do. The sign for cosine will be negative because it's over to the left of the y-axis. This is negative root 2 over 2. And for sine, it's positive root 2 over 2. That's really the sole purpose of me drawing the picture, is just to see which quadrant I land in so I can get my signs correct. All right, any questions on that? All right. It says use the info to find the other two trig functions. So we have cosine of theta equals -4/5, and sine of theta is less than 0. So let me circle this. Just that fact alone tells me that I'm either in this quadrant or this quadrant, right? Sine of theta is less than 0 says that the y-coordinate is negative. So I'm in one of those two bottom regions. Now, the fact that cosine of theta, right here, is a negative number now takes one of those out. It puts me in this region right here. Okay, so that's what we're doing. So it says use the info to find the other two trig functions. So I like to do that first, is I'm going to use the information to figure out which of the 4 quadrants I'm in, and then I'm going to draw my reference angle. So my reference angle here would look like this. It's in this quadrant. I just draw kind of a generic triangle. I'm trying to think, okay, I'm 4 over, and then the radius is 5. Remember, cosine is adjacent of radius. So when I draw my reference angle, it's drawn such that here's my theta, my 4 is here, and my 5 is over here. And one more time, the reason I know I'm in this quadrant is because it said I had to have a sine of theta was less than 0, so that limits it to these two. And then the fact that cosine of theta equals a -4/5 then limits it to this third quadrant, because that's where cosine is negative. It can't be over here. If it said cosine of theta is +4/5, it would be over here. Okay, so there's my picture that allows me to label one of the legs and the hypotenuse, and then I have to use Pythagorean's theorem to find the other missing piece, or recognize it's a triple. Yeah. So in this case, it is a triple. This is 3, or use Pythagorean theorem to find that. That's the only triple you know. 3, 4, 5, and every multiple of that. 6, 8, 10. Okay. 12, 13, 15 is worth memorizing, right? You'll see that quite a bit as you go through this course. And then 7, 24, 25 will show up once in a while. The multiples of 3, 4, 5 will show up quite a bit. All right, so here I have, it says find the other two trig functions. Well, cosine was given to me, so I need to find sine of theta and tangent of theta. And then pay attention to my signs. So sine of theta is going to be, so I'm standing at theta, it's the opposite side, so 3 over the hypotenuse 5, and I need a negative sign on there because I'm below the x-axis. And then tangent of theta, so I'm standing at theta, it's opposite 3 over adjacent 4, and then is it positive or negative for tangent? It's going to be positive, yeah. For tangent, it's these two quadrants where it's positive, so anywhere where the signs are the same. And that's because tangent is a mixture of sine and cosine. It's a ratio of those two. All right, this is called beta right here, in case you're wondering. This is beta, Greek letter beta. And we use that also to indicate angles in trigonometry. So sine of beta is 2/3. Tangent of beta is less than 0. If tangent of beta is less than 0, then I have to be in one of the following two quadrants. Either tangent beta is less, either here or here, because here and here, tangent would be positive. So it's either there or there. Now it says sine of beta also equals 2/3. So the fact that sine of beta is positive limits me to which quadrant of those two? The top one, yeah, so we'll circle that. So there we are. Now, I'm going to draw my reference angle here. Reference angle here is theta. It's coming up from the x-axis. And the opposite side would be 2. The hypotenuse is 3. I'm going to have to use Pythagorean theorem to find x, the length of the adjacent. So I have x squared plus 2 squared equals 3 squared. So x squared equals 9 minus 4 is 5. X equals, we just want the positive square root. We're talking about the length of the triangle. So x equals square root of 5. So I can write x equals root 5 here. So if that's the case, then sine of theta, cosine of theta would equal, sine of theta is going to be opposite over hypotenuse, so that's, what's that? Oh, we have, yeah, let's find cosine and tangent, huh? So we're going to find cosine theta and tangent. Yeah, we already have sine. And actually it's not theta, it's beta. Okay, let's try that again. So we have cosine of beta and tangent of beta. And those are the only two we have to find. So cosine of beta is going to be adjacent, which is root 5, over hypotenuse, which is 3. And then the sine is negative because we're in the second quadrant. We're to the left of the y-axis. And then tangent of beta is also negative. We're told that up here. So it's negative, and it's opposite 2 over adjacent root 5. So opposite over adjacent, we need to rationalize that denominator. Multiply by root 5 over root 5. So I have negative 2 root 5 over 5. All right, so you're drawing reference triangles, drawing the angles coming up from the x-axis, labeling it, finding the missing side, and then using the definition to figure out the missing trig ratios. Okay, any questions on that? So review, I think, for you guys. All right, quotient identities. I had you list these the other day. You needed these to be able to do some of the unit circle stuff I had for you to practice. But a couple of quotient identities are that tangent of t equals sine of t over cosine of t, right? So this is what's behind just learning sine and cosine. And then once you know those, you can figure out tangent and cotangent by looking at the ratios. Tangent is sine over cosine. Cotangent is cosine over sine. And cosecant of t is 1 over sine of t. Secant t is 1 over cosine of t. And then cotangent of t is equal to 1 over tangent t. So this is the only one I didn't give you the other day, was this one right here. That's the only new one. And although this isn't really the goal of this unit, but we have a couple of, like 3 identities to simplify. We're going to do some proofs of identities in the next chapter. But cotangent t, sine of t, that's a product of 2 trig functions. We can create just one by using one of the identities up above. It'll cancel here. Cotangent of t, it says, is equal to cosine of t over sine of t. And then times sine of t. You can see that sine of t cancels, leaving just cosine of t. And so that's a bit simpler. This is right here is called omega. And so tangent of omega, cosecant of omega, we're going to just rewrite these. Tangent of omega is sine of omega, kind of just looks like a W, over cosine of omega, and then cosecant of omega right over here is 1 over sine of omega. And so the sine omegas cancel. And we're left with 1 over cosine of omega. And 1 over cosine of omega is equivalent to secant. So I'll box that. So that product of tangent omega, cosecant of omega can be rewritten as just secant of omega. So that's simpler. There's only one trig function involved there. All right, tangent squared. What we typically do with the powers on trig functions is we write the power in front of what's called the argument. Okay, it's just like with logarithmic functions. This is called the argument right here, what we're taking tangent of. What we mean here is that this is the same as, let me write it up above. This is the way to think about it. Tangent, oh, this is, by the way, delta. So I'll introduce you to my Greek letter. Under delta, you probably recognize delta. Some delta before. So delta, so what we mean is that the whole function is squared. And then we have cosine of delta quantity squared plus sine of delta quantity squared. These mean the same thing, okay? So with trig functions, we write the powers in between the abbreviation for tan is abbreviation for tangent ratio and the argument. So that's what we mean. You should get used to writing it this way, but thinking about it this way, okay? So think about it the way I have it written up here. Write it the way it's typed on here. So tangent squared of delta is the same as, I'm going to replace it with sine squared of delta over cosine squared of delta. And then we have another cosine squared of delta right next to it, plus sine squared of delta. The cosine squared deltas cancel out. So I have sine squared of delta plus sine squared of delta, which is 2 sine squared of delta. So I've simplified that to just one single trigonometric function. All right. That's the very beginning. That's what we're going to do when we prove identities. It'll say, prove that this equals this, and you'll have one little algebraic step. Usually what you do is you do some kind of trigonometric substitution, one of these other identities. So you're using other identities to prove the identity that you're asked to prove. It's like in geometry. So oftentimes proving something you maybe already knew to be a theorem or fact. It's just you're not able to use that theorem to prove it directly. You have to use other properties and theorems to prove that one. Same thing here. All right, so number 6 is asking you to do actually what I asked you to do on that worksheet. Let's just see if we can go through these here. 7 pi over 6. I like to just quickly draw my little picture there to put me in the right quadrant. From that picture, can you tell me what cosine is 7 pi over 6? Sine is 7 pi over 6. And tangent is 7 pi over 6 is. Let's see if we can do this. Can you do it without looking at your unit circle? No, if we're there yet. We're going to do some more practice with this. But cosine is 7 pi over 6. The way I think about it is I'm farther out than I am down. So it's going to be the one where you have, it's going to be negative root 3 over 2, yeah. And if the cosine is negative root 3 over 2, then the sine has to be 1/2, and it's negative 1/2, yeah. And then tangent is a linear combination, or not a linear, a ratio of the two. So I should have done sine on top and then cosine, but if you picture it as negative 1/2, maybe we'll do our arithmetic over here. So it's a negative 1/2 over negative root 3 over 2. What does that end up being? Do you remember? Yes, this is the root 3 over 3 one. If you can remember that, that will save you some time. If you're not having to flip, cancel, you get 1 over root 3. Remember, 1 over root 3 reduces to root 3 over 3. And if you can recognize that when the root 3 over 2 is on the bottom, it's Root 3 over 3 is the answer. And when they're switched around, it's just root 3. Okay. So, that'll help. 7 pi over 3, 7 pi over 3, if I draw a quick picture here. 7 pi over 3 is actually, we go all the way around once, and then, right, 6 pi over 3 would be 2 pi, so we go all the way around once and then up just a little bit here. So there it is. There's my little picture. So can you roll off cosine of 7 pi over 3 now with our picture sitting there? Sine is 7 pi over 3, and tangent 7 pi over 3. Oops, I'm at pi though, huh? Not quite the right picture. Get up higher. I'm high on the circle here. That'll be better. So now, looking at that picture, cosine, I'm not as far out, right? Farther up. So not as far out. I'm going to be, cosine 7 pi over 3 is just going to be just a half out. Just a half right here. And this is going to be root 3 over 2. So sine is root 3 over 2. And then when you do sine over cosine, this time it's root 3 over 2 over 1/2. See how that, if you compare this or contrast this with that, you'll see that in this case the 2's cancel, leaving just root 3. I like that one better. It's easier to remember, easier to see. So that's the root 3 one. All right, something like 7 pi. If I draw a picture of 7 pi, I'm going to go around once, twice, 3 times, and then land right over there. So I'm right there on the x-axis, actually at the coordinate -1, 0. So using that, I could say, okay, cosine of theta has to equal -1. Sine of theta is 0. So cosine of theta is the x-coordinate, sine of theta is the y-coordinate, and then tangent of theta. So you're going to be 0 or undefined, right? In this case, tangent of theta is 0, yeah. 0 over 1, 0 over -1, if you will, which is 0. Okay, and then 7 pi over 4. 8 pi over 4 would be around once. So 7 pi over 4 is going to take me all the way around to right here. If you think about the coordinates right there on the unit circle, this is the, it's the pi over 4 angles I like when it comes to calculating tangent. Those are nice. It's either 1 or -1. So cosine of theta is positive root 2 over 2. Sine of theta is negative root 2 over 2, because I am below the x-axis. Tried to draw it so it looks like it's right at that 45-degree reference angle. And then tangent of theta is a mixture of these, is a ratio of these two. It's going to be -1, yeah. So you're going to do some more practice on that right now. Remember your partner from the other day?
I remember